Okay, so here's section 9.2, question number 1. So, all right, so on this one it says the commercial for new Meat Man barbecue claims that it takes 13 minutes for assembly. A consumer advocate thinks that the assembly time is higher than 13. The advocate surveyed 12, so here, let me write there. There's the claim right away. The advocate thinks the assembly time is higher. Higher. Assembly time higher than 13. So there's some group that thinks that it takes longer to set up this new Meat Man barbecue, higher than 13 minutes. So how do you write that in math terms? Now, we're not going to use P here because this is not a percentage. Notice there's no percentages. That's what this section 9.2 is all about. It's all about means, not percentages. So we're talking about the mean, the average time to set up the brand new barbecue. It's higher than 13. The P is higher than 13. Oh, not P, I'm sorry, the mu. So we use the Greek M. It's an M really, but it's a Greek M which looks like a U. It's mu, and it's an M standing for mean or average. We're saying the average is greater than 13. Okay, and then we're going to write HO, and we're going to write H1. What's HO going to be? It's always same number, same letter for both these, right? Remember, whatever letter and number you have in the claim, the HO and the H1 are always the same letter and the same number. Mu 13, mu 13, mu 13. The HO is always equal. And then one of the two always has to match the claim. So the H1 will be the same as the claim. Let me write claim right there. And then remember, we always write weak evidence by HO, strong evidence by H1 every time. All right, so let's do it. And we're going to choose mu here. We're testing mu. HO is mu equals 13. H1 is mu greater than 13. So now we go to our calculator. And this time when we go to our calculator, you can see over here, so if we go to our exam 3 notes, here's the exam 3 notes. We see that the hypothesis test for mu is equal to the number. And so that's what we're going to do here. We're going to go over and we're going to test this. We're testing mu like that, mu equal to a number. And so the test statistic is, okay, so let me go show you. So here's what you have to do on the calculator. So in fact, here's number 4. Here's where we really need to look. So this question is a mu question, which means it's an average or mean question. So looking at the exam 3, this is the exam 3 notes. Looking at number 4, it says if you have a P, you do the 1 prop Z. If you have a mean, then you have to decide if there's no data or if there's data. So in this situation, we have no data. See what I mean? There's not a list of numbers. We'll see one in a minute with data, where they just have like 17, 23, 49, just a list of numbers, a data list. We don't have that here. So ours is a no data given situation. So where do we go? We go to t-test and choose stats. So on our calculator, we first go to stat and then tests, stat and then tests, and then you choose t-test, which is number 2. And the first thing it'll ask you is it'll say, do you want data or stats. We choose stats, meaning we have some summary statistics. We have things like, this number and this number. Choose stats, and it'll ask you, come back over here, choose stats, it'll ask you mu0, x bar, sx, in, and that. So, so it'll ask you mu0, x bar, s sub x, in. So, what's our mu0? Well, remember what that little sub-0 always tells us to go find? Go find the number next to h0, right? It always tells us to go there. So that'd be a 13. That little 0 tells us to find the h sub 0. And then the x bar, that's always average, isn't it? X bar is always average. What's the average? It says their average time was 14.2 minutes. And s sub x, that's always standard deviation. Standard deviation, 3.2. And, n's always the total number. How many? 12 randomly selected people. So that's 12. And the last thing is you do exactly what H1 says, greater than. And we just get that from H1. Hit enter on your calculator and it'll give you the numbers. So I just did it, and here's what I'm getting. I'm getting a test statistic that says T equal to, see, it wants 3 decimals. 1.299. So if I run around that, there's 3 decimals. 1.299. And then it wants a p-value, which is 0.1102. 0.1102 to 4 decimal places. All right, so now we got to try to make a conclusion. Remember what we always do here. We have to compare the, let me get this out of the way. We have to compare the p value, which is 0.1102, with the significance level. Where's that? There it is, 01. So the significance level, and you always put the significance level off to the right of the p-value. Put them side by side, p-value on the left, significance level on the right. And now, and you make the same number of decimals, so it's easy to compare. There are 4 decimals, 4 decimals. So which one of those is bigger, 1102 or 100? Well, 1102 is bigger. So the p-value in this case is larger. So this p is not low, is it? That p is not low. He's larger. So remember the statement now. If the p is not low, the HO does not go away. So if the p is, let me write that again, squeeze it in a little bit better. If the p is not low, the HO does not go away. So the p is not low, right? The p is greater. So the p is not low, so the HO does not go away. What does that mean? If the HO is not going away, then we're keeping the HO. And the other guy's going away. We fail to reject the null. We fail to reject the null. We're keeping the null, right? If the p is not low, the HO does not go away. We're not letting it go away. We're not rejecting it. We're failing to reject the null. So here we say the p-value is greater, and this means we fail to reject the null. All right, and that means we believe that the evidence, the statistical evidence, is on the side of the HO, not the H1. All right, let's come in here then and draw a conclusion to this problem. So what's our conclusion? Let's try it out. The data suggests the population mean is not significantly higher than 13. Is that true? Yeah. We're saying the average, the mean, is equal to 13. Over here it had greater than 13, but we rejected that. We're saying not greater, not higher than 13. Right? We're saying equal to 13. The greater than option here, let me put it back in black the way it was. The greater than option we rejected. So it's not higher, not greater. So that looks good. That's right so far. So there is statistically insignificant evidence. Was the evidence insignificant? Yeah, it was weak. That's insignificant. If something's insignificant, it's small, it's weak. Yeah, that one's looking good. Let's make sure the other ones are wrong, just to be really, really sure. Says the data suggests that the population mean amount of time to assemble the meat man barbecue is not significantly higher than 13. That's true. So there is statistically insignificant evidence. Oh, that looks good too. Maybe I better read on. That one looks good to there too. There's statistically insignificant evidence to conclude that the population mean time is higher than 13 or equal to 13. Those are close. So there's statistically insignificant evidence. There's not enough evidence to conclude higher than 13. Oh, it's this one actually. That's tricky. Let me explain why. That is pretty darn tricky. I almost got tricked there. You see, they're saying, I know it's really probably seems really confusing. It's saying there is statistically insignificant, meaning insignificant means not strong enough evidence, right? Insignificant evidence. If it's insignificant, it's too small, right? Not strong enough. It's weak. That's our case, right? Weak. Of course, you might say, well, yeah, they both say that, right? They do, but read on. There's not strong enough evidence to prove that it's higher than 13, right? That's what we were trying to prove. That would have taken strong evidence to prove that the average time for setting up the barbecue is more than 13. There's not strong enough evidence to prove it's higher than 13. That's correct. That's exactly right. That's why we did not agree with the more than 13 and we stayed with the equals 13. Whereas up here they're saying there's not strong enough evidence to prove it's equal to 13. No. We ended up saying it's equal to 13. So that's not right. There's not strong enough evidence to prove it's higher than 13. That's why we didn't go that way and we stayed with the equals 13. That's pretty tricky. Pretty tricky. So here we are, question number 5 in 9.2. So, see, this one has a list of data. Clearly, right there, big old list of data. So first thing you do is put that data into L1. Put data into L1 on your calculator. Remember, you hit stat, and then it's already on the edit menu. And you just put that data. So before we do anything else, let's put that data, one big list, straight down L1. Okay, so I just put all that data in L1 in my calculator. Now, let's write the claim. What's being said? On average, a banana will last 6.4 days from the time it is purchased in the store to the time it is too rotten to eat. I just ate 2 bananas today that were getting close to that limit. Is the mean time to spoil less if the banana is hung from the ceiling? In other words, does hanging it from the ceiling make it spoil faster so the spoil time is less? Is that bad for them? The data show results of an experiment with 14 bananas that are hung from the ceiling. So here they are. So there's our data. Like I said, put all that in L1 with stat edit. Let's write out the claim now. What's being claimed in this problem? Is the mean time to spoil less? Less than what? 6.4 days. Less than the usual spoil time if you hang them from the ceiling. So mu, right? It's not a p problem. It's a mean problem. It's not a proportion or percentage. It's a mean. That's what 9.2 is all about, averages. Less than 6.4. Let's write the HO, H1. HO and H1 always have the same letters, same numbers. Mu 6.4, mu 6.4. HO is always equal. And then one of the two has to be identical to the claim. So that's going to have to be H1, less than. It's identical to the claim, and we write claim right there. And then we do our weak evidence, right? The HO always comes from weak evidence, and the H1 always comes from strong evidence. If we've got it, we'll see. All right, then we go to our calculator. Now, looking at the notes here they are, the exam 3 notes. Mean, data given. That's where we're at. We have a big list of data. Put the data into L1, go to t-test, choose data, and then you'll get those options. So I'm going to go to t-test. And this time when it gives me the data or stats option, I'm going to choose data. And it's going to ask me mu0, list, frequency. So what is mu0? Remember what mu0 is? That 0 tells you to go to the h0. I should have put that in here. This was mu. The h0 was mu equal 6.4. This was mu less than 6.4. So the mu0 always says go to h0 and grab the number 6.4. The list, that's going to be L1. It's going to be L1 because it's asking you, where's the data? Where should I go to grab the list of data? Well, we put the data in L1. So, and frequency, we just always leave that at 1. We're never going to mess with that. That just means every number in the list only occurs one time. Okay, and now it's going to ask you greater than, less than, whatever. So you choose less than because that's what you have there. That's always taken from H1. Hit enter and you'll get some numbers. I did it. I'm getting some numbers. Here's what I got. I got a t value. T equals minus, what's 3 places? Minus 2.249 minus 2. Whoops, it's not coming out very clear. Minus 2.249, right? Because it's 89, right? 2.2489. That rounds to 9, and then 4 decimal places on the p-value. I'm getting 0.0212, 2124. So yeah, it just rounds to 0.212. All right, so there's my p-value and my test statistic. Okay, so now it's time to draw a conclusion here. So remember what we do. We let me get rid of this so we have a little more room. We put the p-value, which is 0.0212, and then we put right beside it the significance level. And what's that? That is right there, 0.5. 0.5, and just add a couple zeros so they're easy to compare, same number of decimal places. So which one of those is bigger? 212 or 500? 500 is bigger, right? It goes that way. So, right, 500 is bigger than 212. So is our P low on this one? Yeah, it is. P is low, isn't it? Right, because the P is less. The P is the lesser one. It's less than the significance level. So you know what that means, right? If the P is low, HO must go. If the P is low, the HO must go, and we mean go away, right? So I'm going to go back and cross out the HO. The HO goes away, and I keep the H1, don't I? Right? If the P is low, the null must go away. Bye-bye null, and I'm going to keep, right? So we are what? We are rejecting the null. Right? If the P is low, and it is low, the P is less than. If the P is low, the null must go, meaning we're rejecting the null. Crossing out the null. So this p-value was less than alpha, and so we reject the null. And now let's try to come up with our final conclusion to the matter. What does that mean overall? Well, is it the first one? The data suggests the population mean is not significantly less than 6.4. Is that true? No. We did. We concluded this, right? And we're saying it is less than 6.4. So that's wrong. They said it's not less than 6.4. No, it is less than. We're concluding the data, the statistical evidence says that it's less than 6.4. In fact, there's strong evidence that it's less than 6.4. How about the next one? The data suggests population mean is significantly less than 6.4. Right. So there is statistically significant evidence. Yeah, that's looking good. That's looking really good. There's strong evidence for that. What's the third one say? This suggests the population mean time that it takes for bananas to blow if they're hung from the ceiling. The next one says is not significantly less. No. It is less. So that's out. So there we go. We were able to draw that conclusion.